Hello, ladies and gentlemen. This is Mr. Boyd. Today I'm coming to you from home on video because I don't feel so well. So hopefully this video will make sense and will help you with today's lesson. So today's focus is H7-14. We're going to be writing equations from graphs. Pardon my voice. Like I said, I'm not feeling very well. For those of you, this is the year 2022 right now. Those of you that finished your H7-13 in-class work from yesterday, I will give you details on what we need to do with that either tomorrow or once I return. So please make sure that that is finished, okay? And also, depending on when I return, we'll probably end up pushing the quiz back until next week. Yay, right? I know. Okay, so more details on that later on. Here we go. We will be writing possible equations given a graph of sine or cosine. It says first we must identify the amplitude, the period, the phase shift, and vertical shifts. Then we can construct equations. There are many possible equations which may be correct for each graph. Okay, so I'm going to alter that just a hair. Right now we don't need to focus on the phase shift right at the beginning. We'll get the phase shift when we need it. Okay, so looking at the first graph, you see we have a sine curve, or as some of you call a squiggly wiggly. Okay, so let's look at it here. We've got, you can see how it's going up and down, and we know that the sine function, right? When we're talking about sine functions here, they start on the midline. So there are multiple places where we could start. We could say, hey, I want to choose this point that's on the midline, and I want to focus on coming up with the equation that starts there and goes to here. Remember, it goes on and on forever, but this would give us an adjustment for like our phase shift. Okay, some of you may want to look at this one, right, that starts right here and say, hey, well, I like this because it starts there, it goes up first, and that one there may be an advantage there, right, because it doesn't have a phase shift. It's at 0, right? It goes there. Or we could have, something that maybe starts over here, right, and goes down, back up to there, right, as it goes through one period. So there are a variety of options here. I'm going to ask as you go through this notes packet here, and you may work with the people at your table, I would like for you to find 2 different sine equations and 2 different cosine equations for each graph. Okay, so we'll do this first one together. So I'm going to kind of mark my starting points here. We'll come up with the equations for each of these ones, right? So let's say, right, this one is starting point 1. Let me make sure I use my same values on the key. Yeah, so I said that was number 1. Let's call this one maybe number 2. And then this one could be our third possibility for starting a sine function. Okay, so let's take it here and let's try it. So first thing we need to do is we need to come up with what our amplitude and everything is here. So remember, amplitude is the distance between our midline, which looks like it's the x-axis, and our maximum. So as we look here, right, we've got that distance here. Looks like it's 2 units, right? So we can go ahead and throw that on there. Our period length, right, I would just choose like where does it start at 0 here, and then see how long it takes it to get through one full cycle. So it looks like it makes it all the way to here. So this is 0, and then this goes all the way to 2 pi. I know it's hard to see because I just covered it up, but that would tell us there that our period length is 2 pi. Phase shift, let's not worry about at the moment. And then it looks like we don't have a vertical shift. That would be like 0. Okay, so if we were trying to come up with our equation for our sine function, let's go ahead and start with number 1. Right, for number 1, we could say, hey, we've got y is equal to our amplitude, which we just said was 2, times the sine. And then in this case, right, we are horizontally shifted back to the left, right? What is that coordinate? Let's take that off there. It looks like negative pi over there. So we went back to negative pi, which means that our phase shift for that one, right? If we're at negative pi, that means we probably had to add pi. So we're going to say theta plus pi. And then we don't need any k value because it hasn't been vertically shifted. So there is one possibility. Let's go to the second one. Okay, so the second one here, I like this one because, right, it's starting right at the origin. So if you notice there, right, the amplitude isn't going to change on any of these, right? The amplitude stays the same because the distance between the midline and the max or min is going to be the same. So we're going to say y is equal to, oh, you know what? I forgot something on the previous one, didn't I? Right? Ooh, so this is an easy thing to forget. When we look at this one here, what's going on? We're going down first, right? So when we go down first, that means we're going to need a negative value on our 2, right? We need that negative up there. I forgot that. So see how easy it is to forget it? Okay, so just make sure you're careful. Because this one now has positive, right? So we're going to do positive 2 times the sine. And if we don't have any phase shift, right? If this one hasn't been shifted at all, then we'll just say of theta. And then our third one, right? Our third one here, we've got, looks like it's another negative 1. Amplitude hasn't changed, so we know this is going to be y equals negative 2 times the sine. And in this case, since we are going to the right, right, we're shifting to the right this way, looks like pi units, right? We'd say theta minus pi, and then we don't need a vertical shift. So those 3 equations should all give us the same graph. Okay, so let's jump in and look at cosine now, right? I'm going to take this, I'm going to erase what we have on here so we can just focus on the cosine. Now remember, cosine typically starts at the maximum or could be the minimum if it's vertically flipped. So I'm going to say we could start here. We could start up here, right? Or maybe even throw one more on there. We'll do 3 different options. Okay, so we'll call this like option A, call this option B, and call this one option C. Right, and then just think about it, right? So option A, right, if we go through one full period, it's still traveling a distance of 2 pi. Our B, right, you can look at it here, goes down, comes back up to there. Or C, looks like it's another negative 1, right? It goes from here up and then back down. Okay, and then they continue to go on and on forever. So we'll come up with equations for each of those. Excuse me. Okay, so let's start out with A, right? So as we look at A, right, we know here that our amplitude is still going to be 2 units, right? Whether you're going down to the bottom or going up to the top, it's still 2 units. So the amplitude stays the same. We already said our period length will stay the same. Our phase shift is going to change depending on where we start. And then our vertical shift should stay the same. So in this case, right, since we're starting on the bottom, we know that we're going to have y is equal to, and we'll say a negative 2, because we're starting on the bottom, times our cosine. And then we're going to have, let's see, our phase shift, right? If we're going back to negative pi over 2, that means we need to add pi over 2. So we'd say theta plus pi over 2. Let's look at B. So for letter B, we've got starting at the top, right? So we're starting up here at the top, and we're going down and back up. So we already know that on this one, right, it's going to be y equals a positive 2 times the cosine. Our phase shift on this one, we've gone forward pi over 2, which means we need to say theta minus pi over 2 in our equation. And then, again, no vertical shift. And then our last one, right, maybe you chose this one. Let's see. So, again, this one starts at the bottom. So we have y is equal to negative 2 times the cosine. And on this one, we've got, let's see, theta. And in this case here, we've shifted to the right 3 pi over 2. So we need to say minus 3 pi over 2. And that would be a possible answer. Okay, so now how do we check these? Okay, everybody's got a graphing calculator. So if you want to grab it out, Okay, let's go in and make sure your mode is in radians. Okay, and then I'm going to go in here, and if we look here at what our window is, right? Our window goes from negative pi all the way to, it looks like 3 pi. Okay, and then it looks like it goes from -3 to +3, or you could go from -2 to +2. So let's type that in here. So we're going to go into our window, and we say our x min, which I already forgot, holy cow, was negative pi. So just type that in, right? So we'll clear this out, clear, delete. All right, so we have negative second pi. Our x max, we said, was 3 pi. So you just type that in. It'll turn into a decimal. That's okay. Our scale there, I don't know what the scale is going by. I didn't look at that. So we have like, looks like pi over 2's. Okay, so we're going to do second pi divided by 2, right? So it's like 90 degrees, but we're in radians. And then we can do -2 to +2, and the y scale doesn't really matter. Okay, so now we'll go into our y equals, and let's type in some of those functions here. And ideally, what's going to happen here is they're all going to give us the exact same graph. So as we look here at number 1, right, we said y equals -2 times the sine of, and now remember, we can't put theta in there, so we're going to use x. Okay, and then we have plus pi, and we'll close it. Our second sine function we said was 2 times the sine of just theta, or x. And then we also had a -2 times the sine of, what was that one? Theta minus pi, I believe it was, or x minus pi, because we shifted to the right. And then tell you what, let's just go ahead and put in our cosine functions all at the same time, right? Save some time here. So we've got -2 times the cosine of x plus pi over 2. Then we had 2 times the cosine of x minus pi over 2. And did we do a third one? I don't remember, but we'll put one in anyway. I got another one here for us. So we had -2 times the cosine of x minus 3 pi over 2. Okay, so when we look at our graph, right, all you see is one graph on here, which is a good sign, because if you see multiple graphs, then one of your graphs is off. Okay, but we have all of our functions are on here, right? So they all overlap because it's all going to give us the exact same function. All right, let's go back to it now. Okay, so I'll let you go ahead and try number 2 on your own. Okay, so just think about here some of the places that you could look to start, right, for your sine functions. For your sine functions, we could go ahead and we could think about starting at like right here, right? You could call that number 1. You could call this number 2. You could call this number 3, right? You don't have to do all of these. I'm just trying to throw out some options for you, right? And then we also have cosine functions. So, right, we could say, hey, this is going to be like A. This one could start here and be B. This one could start here and be C. Okay, so you have some different choices, some different options there to come up with the values. So I'm going to jump into the next one. Now, all these answers will be in Schoology, so you can check your functions that way as well. Let's look at 3. This one's only asking for possible sine equations. Okay, so as we look at it here, it's obviously got a vertical shift to it. Okay, so we're going to have to figure out, so since we have a sine equation, right, let's look at it here. We know that right now this is where our midline would be, running right through the middle. So that kind of tells us that our midline is at -2, so we have a vertical shift of -2. If we measure from our midline up to our max or our midline down to our minimum, we can see that that's just 1 unit, right? So our amplitude is just 1. And then our period length, well, if we start at 0, we could say, hey, this starts here and it goes all the way to here before it repeats. So it looks like, again, we have one that's just 2 pi. Okay, and those ones are probably going to be a little bit easier for us. Okay, it's when we have to find our period changes that might be a little bit more challenging. Okay, so we know our period is 2 pi. And then our phase shift, remember, is going to vary depending on where we choose to start. So let's just look at like 3 different possibilities. I'm going to write out here, we've got number 1. I'm going to write out here, looks like we have number 2. And then maybe we'll do this one right here, which could be number 3. Okay, so since we're talking about sine functions, right, we're just starting on the midline. So the first one here, right, it's going to start here and it's going to go all the way through, right, to there. So as we look to write it out, we've got number 1, we'll say y is equal to, and this one looks like it's a negative sine function, so we're going to say a negative. And since the amplitude is 1, we'll just say negative sine of, and then it looks like we have been shifted back to negative pi. So we'll say this would be theta plus pi. Okay, and then remember on this one, since we have our vertical shift down 2, remember we went down 2, negative 2 is going to equal our k. So we need to have at the end of this minus 2. Looking at the second one, right, we've got y is equal to, now this one opens up, so we're going to have a positive sign. It doesn't look like it's shifted left or right, because it's right on the y-axis, so we'll say theta, and then we'll throw in there our minus 2. And then our last one there for this one, we'll say, all right, for number 3, if we started here and we're looking at extending it this way, okay, we'd say y equals, it's obviously negative, so we have negative sine of theta, and then since we've shifted to the right, 3 pi over, I'm sorry, not 3 pi over 2, I went too far. Looks like we've gone to the right pi, right? So we're going to say theta minus pi, and then we'll throw our minus 2 on. And again, feel free to graph them on the calculator to check them to make sure that they're all the same. All right, so let's move on here. I'm going to leave you number 4 to go ahead and try on your own. And we're going to look at number 5. Let's look at number 5. So again, this one's asking for a sine function. Okay, so as we start to analyze it and look at it here, it looks like it's cycling a little bit faster, right? Because we've got some different possibilities for our values here, right? And I have I think like 6 of them on the answer key, right? So I will just do probably like about 3 of them, but you can do whichever ones you want. I'll just do like maybe these 3. So this was my number 1, this was my number 2, this was my number 3 options. So looking at 1, okay, as we look at this here, this one starts here, goes up, down, back to here. Okay, well, we've got, looks like an amplitude of 1. Our period length goes from negative pi to 0, which means we have spanned pi radians. So this one does have a period change. We're not going to worry about the phase shift right at this moment. And then our vertical shift looks like it's 0. So let's talk about how to deal with it when we have a period change, right? This is important. Remember, there is that formula for the period change. Our period change, or I should just say our period length, right? Our period length is always going to equal 2 pi divided by b. Okay, so if that is what our period length equals, and we already know that our period length on this one is pi, so what we're going to do here, let's just set this equal to pi. So 2 pi divided by something equals pi, right? And then let's just go ahead and solve it. to figure out what b is, right? So we can cross multiply here, and we've got 2 pi times 1 would be just 2 pi, and then b times pi would be pi times b, and then to get rid of pi, we'll just divide each side by pi, and you'll see here the pi's will cancel, and we get 2 is equal to b. So that is our b value. So I think that these ones are easiest when you write them in, excuse me, factored form. So remember, your factored form looks like this. We'd say y is equal to a times the sine of, we have b times in parentheses theta minus h, right? And then we have plus k. Trying to write it with the b theta minus bh is a little bit more challenging, but there's always a few people that still do it that way, and that's fine if that works for you. Okay, so here we go. Let's go ahead and start building this one. So our amplitude we said was 1, and this one's positive, right? It's going up first, so we have y is equal to, we'd say, the sine. And then since our b is different, right, our b has a value of 2, I'm going to go ahead and put 2 in there. Open parentheses, there's my theta. And then now, because I'm doing it this way, right, I can see that my phase shift is back pi units. So we're going to the left pi units, which means we need to add pi there. Right, and then at the very end here, right, we'd have our k value, which in this case is just plus 0. If you want to write it in there, you can, but it's not necessary. Okay, let's look here at number 2. Option 2 starts by going down, right? It goes from here and then up and then back down. So we know that we're going to have y equals a negative sign, and then nothing else really is impacted by that, right? Our period is still the same, so we're still going to use b as 2, and then we'll say of theta, and in this case we've gone to the left pi over 2, so we're going to say plus pi over 2. And then again, you can put plus 0 if you want, or you don't have to. And then our last one there for this one, we have number 3. We've got y is equal to. This one obviously here is a positive one because it's going up and then back down. And it looks like it doesn't have any phase shift, so we're going to say y is equal to the sine. And since there's no phase shift, we can go ahead there and just say of 2 times our theta. And then if you want to put plus 0, you can do that. Okay, so that should give us the same thing. Okay, so I'm just doing examples to help people out who might be stuck. At any point in time, you can stop watching and finish this out, and then check your answers in Schoology, and then start your homework. Yay! All right, so let's do another one here. Let's do this next one just because it has a different period length as well. So this one says a possible sine equation. Okay, so I mean, I guess we could do that. A lot of signs, but we'll do it. So a sine, right? We could start here, we could start here, we could even start over there, right? But let's just start out here with the first one that's right at the origin. That one should be the easiest for us, right? So we'll call this one number 1, call this starting point number 2. So we'll just do 2 on this one. So for number 1, okay, as we look at our information, right, looks like our midline, right, is on the x-axis, so our amplitude is 1. Right, you can see that it's 1 in both of those locations. So amplitude is 1. Our period length goes from 0 all the way over to 6 pi before it starts to repeat itself. So again, we can use that formula, right? Our period length is going to equal 2 pi divided by b. And in this case here, right, we said our period length is 6 pi. So if our period length is 6 pi, we got to figure out what b is going to be. Right, and again, you can cross multiply. You have 6 pi b is going to equal 2 pi. Then we'll divide each side by 6 pi. And in this case, it says b is going to end up equaling, pi's cancel, 2 over 6 is really 1 over 3, which makes sense, right? Because this one's going much more slowly. So our b value is 1/3. So with our first one here, we said that our period length was 6 pi. We know that b is 1/3. There is no vertical shift, and our phase shift is going to vary depending on our starting point. So here we go. We're going to say y equals, right? And we're talking about this first one, number 1. So y equals, it's positive because it goes up first. It's the sine function. Okay, and then we're going to put our bracket. And then we've got here our b value, so 1/3 times the quantity of, well, in this case, it's just theta, right? Because we have no phase shift. So I know I put brackets in there. If you put parentheses instead, that's okay. And then if you wanted to put the plus 0, you could do that. So that is option 1. Option 2, we'll say y equals. Obviously, this one is going to start by going down first, then up, and then it's going to go off the graph. Okay, but we should say negative sine of 1/3 times, in parentheses, theta. And then if we have shifted to the right 3 pi, we would want to say minus 3 pi. Then we will close it, and then we'll say plus 0. All right, hopefully you're not getting tired of listening to me. I'm sorry. My voice is a little raspy. I'm on my deathbed. What can I say? I'm trying to survive here. So, why don't you go ahead there, and I'll let you do the 7. I'll let you do 8, and the rest of them there, basically. So just make sure you're paying attention to the period lengths that might be changing, right? So 9, we may have a different period length. 10, looks like it might be 2 pi. So 11 might be just 2 pi. So lots of 2 pi's in there, so which should make life a little easier, but go ahead and make sure you try those ones. And once you're feeling good about it there and you've checked it there, you may get out the homework and begin working on that. That's H7-14. Please make sure you pay attention to remind. If I'm going to be out the next day, I may alter the assignment or alter the homework. I will let you know just so that you are aware. All right. Thank you for working hard. I appreciate it there. Please be nice to the substitute teacher. Anybody gets a bad report, I won't get any bad reports because we're all good kids. So I appreciate that. So have a great day, and hopefully I'll see you soon.